Hi everyone. We are moving on in section 4.5, graphing sine and cosine. So far we've unwrapped the unit circle to get our default sine and cosine functions and their graphs. We've explored the amplitude and period using Desmos, and we've learned the formulas to find amplitude and period if they weren't the same. And then last week we took a look using Desmos.com to change vertical shifts, some reflections, the amplitude and periods, and we were able to create the equations of the graphs and to see how it changed them horizontal and vertical transformations. Today what we're going to do is we're going to actually use that knowledge of the parent functions of sine and cosine and these properties, and now we're going to actually graph them ourselves by hand. Okay, so the first step you're going to do is we're going to take a look at our graph when we're given it to us, and then we're going to determine our amplitude and our period and see how that changes our original function. So when I take a look at this, we're going to say what our amplitude is. So we know that the amplitude is the absolute value of A. So in this case, the A value is 2. So the absolute value of 2 is 2. So our amplitude is 2. And our period is 2 pi over b, which in this case is just 2 pi over 1. So our period is 2 pi. Okay. So we notice that the period does not change. So the horizontal transformation stays the same, but we do realize that we are now going to have a vertical transformation, which is going to be a vertical stretch we found out last week. And we took a look at this on Desmos as well because our amplitude of 2 is greater than the regular amplitude of 1 that we see for a sine curve. So going back to our original sine curve of having 0 here, okay, and here would be pi over 2, which goes up to 1. And then we have pi, and then we come down here, 3 pi over 2 is 1, and we go to 2 pi. Okay, and then we see that that's the original sine curve from here to here. And I'm going to plot this very quickly, the best that I can. Okay, and then what we're going to do is we're going to take a look at what's going to happen. Okay, so what's going to happen if I vertically stretch this to an amplitude of 2? So the equation at 0 is still going to stay at 0. And as we saw in our Desmos activity, that this y value at 1 is now going to stretch up to here at 2. The 0 is going to stay at 0. The negative, okay, is now going to come down to the negative 1 is now going to drop down to a negative 2, which I just realized we need to give us some more room here. Okay, so we're going to show how this negative 1 now drops down here to negative 2, and then the 0 stays the same. And then you'll see, as we did in our exploration, that it does just do a vertical stretch. Okay, and there you have it. So the amplitude of a change of 2, all it did was just vertically stretch it out. Period stayed the same at 2 pi. Now, if we wanted to continue on doing this, okay, so here is the next one. We know that it's going from pi over 2, pi, 3 pi over 2, 2 pi. So this is 5 pi over 2. All right, my next point then is going to be 2 pi, which is 6 pi over 2. So then that means my next one is going to be 7 pi over 2. Okay, and at 7 pi over 2, that means that this is going to come up to positive 2. And then at 3 pi, it's going to hit 0 again. So then that means that this one is going to be 9 pi over 2. And that's going to come all the way down here to negative 2 following the pattern, and then it's going to resume back at 0. And this actually is a whole nother period showing this 2 sine x. Okay, then if we wanted to just show the opposite side of the graph, okay, we would just go in the opposite direction. Okay, remember that sine is a odd symmetry, which we talked about last week. Okay, and then all I really would have to do is just copy this graph on the other side. And we've then graphed many periods of the sine function, and then very carefully just connect our dots, which I know doing this virtually is a little bit more difficult than we've done in the past, but we will make the most of it and make sure that it goes through 0. Okay, so there is our first graph with a amplitude change. Okay, so let's take a look at another one. Okay, so here is our next one, negative 1/2 cosine x. Okay, so our regular cosine graph, we know that the regular cosine graph we've talked about in the past, it starts right here at 1. Okay, so what I'm actually going to do with this one is I'm actually going to make this a 1 here, and I'm going to make this a 2, and this a negative 1, and this a negative 2, just to give us a little bit of room. Okay, so we know that it starts up here at 0, 1, and at pi over 2, it hits here, and then we come down 3 pi over 2, and then 2 pi. Okay, and then on the opposite side, we know it has even symmetry. So we're just going to plot the even side onto the other side of this curve, okay, the y-axis. And then we have a nice, I call it the W graph, or it kind of looks like the bird. Y equals fly here. Okay, and try to get it to hit as close as possible. Okay, so now let's talk about what happens with this amplitude. Okay, as you could tell here, the amplitude's definitely changed. Okay, the amplitude, the absolute value of negative 1/2 is 1/2. Okay, and then if I take a look at the period is 2 pi over the b value of 1. So my period has not changed. The period is still 2 pi. So there's no horizontal shift here. Okay, but the amplitude has changed. The amplitude of 1/2 is now less than 1, which you guys have told me in the past that we found out that this is a vertical shrink. Okay, so that means that my amplitude is now going to change. It's also going to affect my range. The range is now going to go from negative 1 to 1 to negative 1/2 to positive 1/2. Okay, the other thing that we also have to pay attention to is that there's this negative that's chilling in the front of the 1/2. And as we saw last week in the Desmos activity that you guys did a really great job on, is that the negative flips it over the x-axis. So if we were to graph this, I would start here in the middle, right at the point 0, 1, because we know that normally the negative is going to flip it down to negative 1, but because it's shrinking to 1/2, this negative 1 is now going to shrink to the negative 1/2 value. Okay, so this changes to here. 0 always stays the same. Then we're going to start at negative 1. Again, remember, flip it over the x-axis to 1, and then it's cut in half because of the amplitude shrinking. Okay, 0 always stays at 0. Okay, it's like flipping on top of itself. Okay, it's like doing jump rope. Okay, but it just hits right on top of itself. And then 1, it flips down to negative 1, but then it has to shrink a half because of that amplitude change. Okay, so it actually, and we can see here that it shrank a little bit, it shrank a half. Okay, and then it did flip upside down. And if I continue the graph on the other side, okay, all we have to do, because we know it has an even symmetry, is reflect it over the y-axis, okay, and do that exact same symmetry to the other side. Okay, so as long as we do one side, I always do like the right-hand side, we can do the y symmetry onto the other side. And there's 2 full periods of the cosine graph. Okay, so now what I would like you to do in the Nearpod, this is, I will post this so that you have the notes of it, but this is what you're now going to take a look at on Nearpod, and you're going to plot this graph. So if you want to, you could use this graph first to work it out, and then you're going to plot it into Nearpod using the drawing tools.